Hi everyone, Paul here with a very quick introduction to the concept of cognitive load. But this here is just a first quick introduction. Don't be surprised if it raises as many questions for you as it answers. In fact, please do jot down your questions as you watch. You'll have a chance then to share your questions with me and your classmates in a follow-up discussion activity. So here goes. Cognitive load is a key aspect of how we learn, which is to say a key aspect of how data or information out there in the world gets into our brains and is remembered by us over time. How does that happen? Clearly content, represented here by a fascinating looking document from the U.S. Patent Office, can't simply be uploaded directly into our brains. Let's say our goal, very simplistically put, is to get this information into our long-term memory. How can we get it there? Well, research by cognitive psychologists has shown that to get to long-term memory, information first has to be held in a part of our brain circuitry called working memory, represented here by a thimble. Working memory is where information gets worked on, meaning processed or filtered, and crucially it has the characteristic of being very limited in size. We'll get back to that issue of limited size in just a moment. But to finish the story, once information does get processed in working memory, it gets passed along to long-term memory, which is huge, as represented by this bathtub, and which can, in theory, hold millions and millions of thimblefuls of information. But now back to the issue of limited capacity. Research going back to the 1950s has shown that working memory can process only a very small number of items at a time, roughly between 5 and 9 items. And more recent research suggests that on average the number may even be smaller than that. So you see the problem. The information coming at us from the world, in this case the document from the Patent Office, is like a steady stream of water, or in some cases a steady blast of water. And our tiny working memory thimble is constantly in danger of being overfilled and overwhelmed. Why? Again, the research shows that only a very small number of items of information can be processed at once. So what are we to do? And how can we cope with this? And at the same time, how is it possible that some people do appear to be able to keep up? People who can listen to a long and dense lecture on whale migration patterns and remember all the details, or who can look at a few minutes of tape of a football game, say, and then give you a rundown of all the players on the field and what they were doing and what they could have been doing or should have been doing better and so forth. The answer, in a word, is chunking. What is a chunk? Well, to explain what a chunk is, let's look at the text we have here, a mix of 14 letters and numbers. This string is not incredibly long, but imagine it was flashed up on the screen for just a few seconds. Do you think you could look at it, close your eyes, and remember it? My guess is that some of you are thinking, yes, I could, no problem, while others of you are perhaps thinking, geez, I'm not sure I could do that. And I'm further guessing that those of you in the first group, the yes group, are in fact not thinking about remembering 14 items, but instead just 4. And here's why. Some of you, I suspect, instantly recognized that the 14 letters and numbers here were not a random scramble of letters and numbers. Rather, we have 2 years, 1947 and 1953, and 2 names of spy agencies, the U.S. intelligence agency, the CIA, and the old Russian intelligence agency, the KGB. And if you guess that those 2 years given here are the years those agencies were created, you're right. So for some readers, this string did not consist of 14 different things to remember, but only 4. And that's a big difference. For some of us, the capacity of working memory here was not exceeded, while for others, it was. And this is what chunking is all about. Faced with a torrent of incoming information, what is your brain able to do? Are you in a position of having to remember every little bit of information as an individual item? Or are you able to chunk or divide up this incoming stream of information into a smaller number of units? To further explore the implications of this, let's compare 2 brains, the brain of a novice or beginner and the brain of an expert. Let's put the brain of the expert under a magnifying glass. What does this expert have that the novice doesn't, or at least not have as much of, or not to the same extent? Well, things like this: background information or prior knowledge about many topics, like knowledge of the CIA and the KGB that helped us a moment ago. Also, knowledge of schemas and strategies, which are ways of processing information or organizing it. So let's take a look at this expert brain in action. Here it is encountering some texts, a sonnet by William Shakespeare on the left and a journal article about online reading by Julie Coiro and Elizabeth Dobler on the right. Faced with these texts, our expert immediately brings to bear relevant concepts, categories, background knowledge, strategies, and skills. And using these, the expert may not exactly breeze through these texts, right? They will likely still require his or her full attention and some effort, but the expert is not likely to experience cognitive overload. But what about our novice? Right? She and the expert have about the same amount of working memory capacity. Both the expert and the novice are working with their 5 to 9 item limit. However, in the absence of the things that the expert has in her long-term memory, concepts, background knowledge, and so forth, the novice can't do the kind of rapid and efficient chunking or dividing up of new information that the expert did without even giving it a thought. And it's therefore much more likely that the novice will experience cognitive overload. So much for the idea of working memory and cognitive load. Here's where things get even more interesting, because it turns out that there are different types of cognitive load. And they are not all bad. And the fact that there are different types of load therefore opens up the possibility that by reducing the bad kind and keeping only the good kind, it may be possible to improve the overall quality of learning. That's what we'll briefly explore in the last 2 minutes of the screencast. So let's return to our novice learner trying to read and comprehend a Shakespeare sonnet. As she works on that task, our learner is experiencing 3 different types of load on her working memory: intrinsic load, extraneous load, and germane load. What are these? Well, intrinsic load, to start, is the unavoidable work involved in doing any mental task, whether solving a math problem, 6 times 7 is 42, or figuring out why lactic acid buildup is bad for your muscles, right? Those are tasks that involve some amount of load, intrinsic load. By contrast, extraneous load is the avoidable or at least reducible workload caused by the particular way in which information is presented, formatted, or packaged. For example, research has shown that when text about a topic like how muscles contract is displayed on a separate page than the diagram showing how muscle fibers function, your brain has to work harder than it does when text and image are displayed side by side. The text with the connected information on different pages imposes a higher level of extraneous load, the avoidable kind of load, on the reader. Finally, germane load is the mental work associated with creating a new way of organizing information, such as figuring out that when learning about a new country, say, it's helpful to first notice what continent that country is part of. This does use up some amount of working memory capacity, but it's very worthwhile because it's going to help you reduce load in the future. For example, by making you a more efficient chunker of incoming information, right? If I made a point of connecting the country Venezuela to the continent South America, this may help me in the future as I look through a list of countries in connection with a new topic. So those are the 3 different types of load that our learner may experience as she reads that Shakespeare sonnet. And at any given moment in time, our learner is probably experiencing some amount of all 3. Right? The question is, will our learner be able to do the task she's doing, for example, reading that sonnet in order to paraphrase what it's saying, without experiencing cognitive overload, right, causing her to feel overwhelmed, confused, frustrated. Paraphrasing a sonnet is not easy work, so there's likely to be quite a bit of intrinsic load, but that can be okay. A problem arises, however, if there's too much extraneous load and the total amount of load starts to exceed the learner's total working memory capacity, right, going over the limit. For example, if the notes explaining some of the sonnet's difficult vocabulary are presented as footnotes at the bottom of the page in tiny font, right, instead of alongside the sonnet in large font, just that difference could push up extraneous load to the point that our learner shuts down, feeling overwhelmed. But it's important to keep in mind that the total load is the combination of all three types. For example, our learner may have a copy of the sonnet that does present the meanings of difficult words next to the sonnet in large font, right? That's not the problem. But maybe the intrinsic difficulty of the task is just too much. Maybe our learner has never had to paraphrase a poem before, or maybe this sonnet contains two different and opposed perspectives on a topic like love or death. In that case, the intrinsic load related to the intrinsic challenge and difficulty of the task may simply be too much by itself. Which brings us, in conclusion, to our challenge, right? Our challenge as students, and especially as teachers and designers of learning materials and activities, especially texts, right? The challenge of optimizing our use of our very limited cognitive capacity. The challenge of reducing cognitive load whenever possible, and in particular of reducing extraneous load, right? The type of load that's caused by design or presentation choices that could be different and that can be improved. That's it for now. I hope this quick introduction to working memory, to cognitive load and different types of load, and the challenge of optimizing our learning by reducing load hasn't overloaded your working memory capacity. Thanks for watching. We will continue exploring this topic in the next couple weeks.